Hi there, my name is Gregor. I'm a product specialist and customer success manager working for FutureOn. So I'm supporting the integration of use of the FieldTwin digital twin platform with a number of major operators, and I'm also involved in the development of metadata standards for subsea. So firstly, many thanks to Adam and the Future Digital Twin Committee for giving me the opportunity to participate in the conference. For your background, I've been a subsea specialist for over 25 years, working around the globe with different subsea suppliers, service companies and operators, and most recently spent 10 years as a subsea technical specialist for a major operator, working on design tools for subsea and condition monitoring. Now, let's go to the presentation. So my presentation today is based on their FieldTwin platform, and it's to describe the AnyTwin approach, which is a way to enable subsea collaboration and integration by connection between digital twins. So the presentation will focus on the use of this open data platform, the FieldTwin, to support subsea design, digital collaboration, and integration of applications, and how the platform can be used to integrate with other digital twins, and thus helping to provide value, increased efficiencies, and better decision making. For those not familiar with FutureOn, the company was spun out of X-Vision in Norway in 2014 with the creation of the Field Activity Planner, or Field App platform. The Field App platform has been built on and advanced in the last few years into what is now FieldTwin, which is a fully 3D-based web application for subsea design and collaboration, and it incorporates an open API and integrated services. So the platform is now becoming becoming the industry standard for subsea field development and operations with a number of major operators and contractors. The FieldTwin shown in the video on the right is a cloud-based software as a service platform providing a 2D and 3D visualization interface for designing and operating offshore fields from the reservoir to subsea to the topside facility or onshore host. So the primary aim of the tool is collaboration and integration. The platform provides both generic and contractor asset libraries and catalogs with 3D models, which can be dragged and dropped onto the screen, similar to Visio, creating a subsea field, and then connected together using pipeline models, risers, umbilicals, and flying leads. So each asset and connection can then have an associated set of metadata, which describes the functional and physical properties of the equipment. As an independent software company, we're not tied to a specific equipment supplier solution, and we're therefore able to supply an agnostic, independent design tool, allowing the user to build the best-in-class field layout. So the software allows the user to upload or connect via an open REST API, well trajectories, reservoir maps, seabed bathymetry, as well as data from internal and external public map servers. This combination of a 3D representation of the field and equipment with associated technical information is very powerful and can support the detailed development, drilling, installation, operational discussions within a project team and with the selected contractors. So the goal at the end is to provide the field developers and operations teams with the data they need to make informed decisions, improve efficiencies in production, and reduce costs. Over the last few years, the FieldTwin platform has been extended further for use in the renewables domain and now includes wind, wave, and hydrogen power assets and data. So as mentioned, FieldTwin is an open data platform and has been designed based on two key foundations. The first of these is integration. So this is the ability to connect and share data with multiple different platforms, simulation tools, digital twins, and data lakes. As well as the technical challenges connecting to each of these data sources, there's also the issue of data alignment and standardization. And this has to be managed, and this has been built into the core of FieldTwin. The second foundation is collaboration. This is the ability to share data both internally in the organization and externally with partners, suppliers, and engineering companies. So true collaboration also requires strict management and control of the data, making sure each user has the necessary access to quality data to perform their tasks. Increasing the level of data sharing allows more and more teams and digital tools to collaborate. Of course, collaboration is only possible if everyone, or every digital platform or application, is speaking a common language or is able to translate. Unfortunately, as the subsea industry is still in the early stages of implementing the digital twin, many operators and contractors have moved forward with the development of their own specific metadata libraries. because they have their own specific use cases, internal applications, selected app integrations, and design tools to connect to. So this approach has increased the time and effort needed to integrate different solutions. So a common language and translator is essential for connecting teams, applications, and data. And this has been the driver within FutureOn. So with the support of some operators such as BP, Shell, Equinor, Total, we've continued the development of a subsea standard metadata to exchange data on subsea fields. As well as a shared language, it's also important to build the social organization or data patterns and relationships between users' applications, and to share this with the wider community. So this slide shows the project phases from appraisal, select, concept, pre-feed, feed, execution, operations, and then finally decommissioning. And we're showing some of the different design and simulation tools that are required through these different project phases. So FieldTwin is central to this and can flow through all the project phases, providing continuity from select to operations. Some of the integrations shown here during the select and pre-feed phase may actually continue to be used during the feed phase and even into operations. And as additional information is gathered during detailed design, changes are made to drilling well or well plans or top hole locations. This can have a knock-on effect on the subsea field layout and an impact on flow assurance, for example. So you need to continuously monitor and do the engineering on your field. The need to connect and share data runs through all the phases. So the aim of FieldTwin platform is to provide this digital continuity or digital thread throughout the project with a single 3D visualization tool, providing interface and single source of truth for the user. Integrating and contextualizing data from multiple sources, simulation tools and design tools allows project workflows and the creation of project deliverables to be accelerated and with a higher quality. And the ability to share a base of design between operators and contractors, or a digital base of design during the pre-feed and feed phases, I think will be transformative. And there's a lot of work to be done because the data still needs to be aligned, an agreement between the different service companies, engineering companies, and operators on the data sets. This need to collaborate and share field concepts and data sets also extends to partners and maybe government regulatory agencies. So having a digital twin central in your project allows you to exchange these field concepts or operational campaigns and review them collaboratively. And this can now be formed digitally using the FieldTwin Collaborate feature. As the project moves into the operations phase, additional set of integrations is required to provide as-built documentation, live and historical data, subsea surveys and ROV video, integrity management information, quality and maintenance information. Connecting multiple data sets in a single application with a correctly geopositioned location allows the data to be seen in context, supporting better analysis and decision making. And as you can see at the bottom of the slide, the complexity of the digital twin is built up through the different phases, with the as-built digital twin fully developed towards the end of the project execution phase, and then handed over and maintained during the operations phase. Any break in this central digital thread can result in a significant amount of work as a handover is then required as the project moves through each different phase. In particular, the handover of the digital twin from the project team during executions to operations can be a huge task to manage, and it can be difficult to maintain data quality. Of course, once the field enters the operational phase, the need for field development tools does not disappear. New field extension, tiebacks, or infill wells may be added to existing fields, which means there's a need to develop and screen new concepts on operational fields. This is where having a single digital platform which combines subsea field development and operational digital twin becomes invaluable. The project team can develop the new field extension based on an accurate, up-to-date operational digital twin, so this reduces risk and improves the quality of the decision making, and takes into account known integrity issues, anomalies and capacities of the existing subsea system. So digital twins are now becoming standard on energy projects, and a number of the different solutions are available for topside and onshore production facilities. There are also well-established platforms for reservoir modeling and subsurface data, including drilling and wells. However, there is often a digital gap between the reservoir model and the topside digital twin on subsea projects. And the topside digital twin is focusing on the floating onshore production facility, with the reservoir models focusing on everything below the mudline. But if we look at the complexity, or take away the water surface and look below, this reveals the complexity of the field development and the associated technical, geophysical, subsea equipment, pipeline routing information that's essential for modeling, designing and planning and costing of the entire field development. So this is where FutureOn can provide a key role, with the AnyTwin connector providing a bridge between the subsea digital twin and the topside digital twin platform, extending the topside twin into the subsea space. So sharing the data between the two digital twins is critical for building a complete network model for the project. This can now be done instantly by connecting the two models, the two twins. The connector also supports engineering design discussions on battery limits and interfaces, field energy management, chemical injection, and control system design. The connector also enables enterprise workflows and full field concept screening, extending this topside digital twin subsea. The key feature of the AnyTwin design and the FutureOn Open API approach is that FutureOn can connect to any topside digital twin. Connectors are already developed or in development for digital twin solutions provided by FutureOn partners, Bentley and Kongsberg Digital. This AnyTwin approach to connecting the subsea and topside digital twins becomes even more powerful when you consider the role of the twin through the different project phases. The AnyTwin connector now ensures that critical field development decisions, process and production design, and modeling is performed at the full field level rather than within siloed work packages. So we're now connecting the topside digital twin with the subsea digital twin through all the phases. So this approach can significantly reduce the interface engineering and improve the quality of any decision making. As mentioned in the previous slides, Bentley and Kongsberg have partnered with FutureOn, and we've started to integrate subsea data into the digital platforms using the AnyTwin connector. Two examples of this are shown on the slide, with the user able to visualize the subsea digital twin as part of the overall field digital twin. The AnyTwin connector is based on the FutureOn Open REST API, and the framework for the connector is open source, with a goal to encourage the development of more and more connections to external digital twins and platforms. The bidirectional AnyTwin connector allows exchange of network topology, 3D surfaces such as bathymetry, data on assets such as manifolds, Christmas trees, and wind turbines, and technical metadata and costs to be shared. This video is rather quick, but it shows the user within the FutureOn platform creating a new subsea field development. So here we're placing subsea equipment such as Christmas trees, manifolds, pipeline end terminations, and then connecting them with jumpers to adding flying leads, including bathymetry information for the seabed. All the equipment is geopositioned, ensuring an accurate production model and digital twin is available to users. The user can then go to the topside or onshore digital twin platform, in this case the Bentley iTwin, and import the subsea field layout and technical data, allowing a detailed cost estimation to be generated in seconds. In this example, importing multiple field layouts into FutureOn and using the AnyTwin connector allows quick screening of concepts, different solutions, comparison of costs for multiple concepts for the same field. So, to conclude, interoperability is key to enabling the subsea digital twin through the design, build, and operation phases. Having an open platform allows the user to connect to existing digital tools and data sets within their organization, and the field twin agnostic independent approach allows users to connect to the best-in-class external design, simulation, and operational platforms. Using integrated digital design tools for subsea can lead to significant cost savings and accelerate the time to first oil. And using the AnyTwin connector allows the subsea and topside digital twins to be connected, which allows full field concept screening and modeling to be performed from the wellbore through subsea to the topside or onshore facility. So it's a true digital integrated asset model. The AnyTwin approach also enables enterprise workflows that you already have within your organization through the digital twin and AnyTwin approach, and a global approach to field design and operations. Connecting the topside digital twin and subsea digital twins is key to interface management between systems and packages. Using FieldTwin with the AnyTwin connector will help to increase collaboration, improve efficiency and productivity, improve the quality of decision making, reduce engineering time, reduce project risk, and importantly, reduce costs. So that concludes my presentation. Thank you for listening, and I'll be happy to take any questions you have.